What's up everyone, welcome back to the channel. So today we're going to go over a high school algebra problem that we have actually seen, which is an algebraic identity that we are told to memorize, but perhaps we have never seen the proof before. That is the sum of the cubes, a to the third power plus b to the third power. And as we know, the identity says that a to the third power plus b to the third power is going to give us two parts. Or we can say that it's a product of two different terms. So we will actually have a plus b, and then times a squared plus ab plus b squared. Right? Now, keep in mind, when we have the products here, we have to change the sign for the ab term. Meaning, if we have the sum as our final result, then for the AB term, we have to subtract. Or, in other words, we need to flip the sign of it. Similarly, if we try to go back and take a look at the difference version, meaning if we're looking for a to the third power minus b to the third power, we see that here we will follow the same sign. So instead of having a plus b, we'll get a minus b. On the other hand, for the ab term, we will then get a positive or a plus sign. Good. So in this video, I'm going to provide two different proofs of why this identity is true. And of course, we also mentioned that there is the other version, the difference of the cubes. That one, I'll leave it as an exercise for you guys to check. Here we go. First method. I'm going to do the following. Okay, so we're now going to add a fancy zero, meaning that we're not going to change the value of the whole expression, but we are trying to add some terms in between so that it will help us doing factoring. So keep in mind, since the next change is zero, as we try to add some terms, we need to subtract the same term as well so that it's not going to change the value. So what are we going to add? Here is what we're going to do. First, I'm going to add the following term. I'm going to put a plus a to the second power times b. And of course, since we want the next change to be zero, we need to subtract a squared b as well. And now we're going to put one more term. This time, we will put minus a b squared. And again, to have next change zero, we need to add a b squared into our expression. Great. So now we have already finished our setup. Let's see how we can actually factor out. As we notice, there are actually 6 terms in total. And if we have even amount of terms, when we try to do factoring, one of the best way to do this is to group it by some number of terms. So for example, since we have 6 terms in total, we can just try to group them by 2, meaning that we will just choose 2 terms and group together, and then we will choose another 2 terms, group together, so on and so forth. So in this case, let's try to do it like this. We're going to group the first 2 terms together, we're going to group the last 2 terms together, and of course, for the middle part, we'll also group them together. And keep in mind, here is grouping as an addition. So here, I'll just put a plus sign to remind us that here we're not multiplying these 2 together, we're just adding these 2 together. So if we do that, we will get the following expression. For the first parentheses, we can actually factor out a squared because we have 3 copies of a here, and 2 copies of a here. So that we will get a squared times taking off 2 copies, we have 1 copy left, A, plus taking the A square away, we have B here. Now for the second part, we have A and A here, we have B and B here, we also have minus sign and minus sign. So what can we factor out? We can now factor out the A and also the B as well as the minus sign. So I'll use this color to remind us, okay, like this. And then if we factor out negative AB, we now end up with negative and negative cancel out. We take away a copy of A, we take away the copy of B, we only have 1 copy of A left. Similarly, here the negative cancels out, the A has been removed, we take out 1 copy of B, we end up with 1 copy of B. Last but not least, we can factor out B squared on the last parentheses to give us B squared times the quantity A plus B as well. Great. So now we have 3 terms and they all have common factor A plus B. So now we can actually factor out the A plus B and then collect everything else in the other bracket. So here we will end up with just A squared. Here we have plus negative AB. And last but not least, we have B squared. And finally, we can just simplify the things inside of the brackets. So we remove the brackets, plus and minus. We have single negative, so it's giving us negative. So we have minus AB and then plus B. Good. So this is how we get the formula above, and we can now try to see if there is any faster way to do it, because again, this is a little bit tricky as we're trying to add a fancy zero. Sometimes it's not that easy to figure out what we need to add. So let's jump into the second method and we will see how we can get this same results using a different way to factor. Okay, so for the second method, we're actually trying to do something that is very similar, meaning we're going to add some fancy zero in our expression, and then we'll be able to manipulate and try to get the same results back. So this time, how are we supposed to add a zero in our expression? This is what we're going to do. Instead of having just A squared B and AB squared, we're going to add 3 copies of A squared B and of course 3 copies of AB squared. And don't forget, since we want the net change to be 0, we need to subtract the same amount back. So here we're going to have minus 3A squared B minus 3AB squared. So that again, we didn't change the value of this expression. Good. And now we're going to do grouping as well. But this time, we're not trying to group by 2 for all the terms that we have. Here is what we're going to do. We will make it into 2 large groups. First, I'm going to take all the positive terms together, and then at the same time, for the negative term, we'll just group them together. So for the positive term, let's try to rearrange the order of the terms. In this case, we can rewrite as a to the third power plus 3a squared b plus 3ab squared plus b to the third power. And this is our first group. Next, we have the blue part. And as we can see, we can factor out the negative. We can factor out a 3. We can factor out an a. We can factor out a b. So that we end up with negative 3ab times Since we cancel out the 3, we take away one term of A, we take away the B, we end up with A here. And similarly, we can take out the 3, take out an A, take out one copy of B, we end up with one copy of B left as our second term. Good. Now what should we do next? How should we put this together? Well, in fact, if we actually go back to our textbook, we should be able to find out that this is actually the expression of the cube of the sum, meaning this is actually same as A plus B quantity cube. And this is one of the identities that we probably have been told to memorize as well. But this is actually not easy. So keep in mind, we actually have another identity here that we need to use to help us getting the results that we need. So once we rewrite it, we now have only 2 terms, and in fact we can find something in common. We have A plus B here, we also have A plus B here. So we can factor out the A plus B to give us the following. Since we took out one copy of A plus B, here we have 2 copies left, meaning we end up with A plus B quantity squared. For the second term, as we take out A plus B, we end up with whatever that are remaining, negative 3AB. Good. So now we just need to finalize our parts in the bracket and try to get the results that we want, which actually gives us, again, we need to use the identity. What is A plus B quantity squared? Right, A squared plus 2AB plus B squared. And do not forget, we still have the minus 3AB. And therefore, as we simplify it, we get A plus B from here times the second factor, A squared. Now we have 2AB minus 3AB to give us negative AB plus B squared. And that is it. Ladies and gentlemen, here is the second method of showing the identity above is true. Again, I'm going to leave the negative version or the subtraction version for you guys as an exercise to figure out. And you can, of course, try to replace the B by negative B to give the answer. But I would like you to try to use one of the 2 methods that I provided to see if you can actually get the results as well. Okay, if you enjoyed this video, don't forget to like. And if you want to find out more of my other videos, please subscribe to my channel and turn on the notification so that you will not miss any of my new videos either. And if you have any thoughts, you can leave your comment below. I'll check it and see what you guys think. I'll see you guys in the next video.